quarter. Okay, so the rules for adding and subtracting fractions start off pretty much the same. So we just want to change to improper form if possible. There we go. So change it to improper form. We don't want to deal with mixed numbers, pretty much. But the next thing that we do is we actually change to lowest common denominator form. So does anyone know what this means? Can someone tell me? Yeah.
You want to make sure that both of the denominators are the same, but you can do that by like multiplying them.
Exactly, yeah. So when we're adding and subtracting, what we need to do is we need to make sure we can only add and subtract fractions if their denominators are the same. So if we have, say, 1 over 2 plus 1 over 3, we can't just say, oh, well, that would be 2 over 5. You can't just straight ahead add and subtract like you would with multiplication. What you need to do instead is figure out what is a denominator, what's the lowest common denominator we can have so that they both have the same denominator, but we haven't changed their value. So essentially what we can do is figure out what the lowest common multiple is of the denominators. So if we have 2 and 3, the lowest common multiple of 2 and 3 is going to be 6, right? So what we want to do is multiply each fraction so that the denominator is 6. So 2 times 3 gets you 6. So we want to multiply that by 3, that by 3. And then for 3, 2 times 3 gets you 6 once again, but it's the times 2 that we're interested in here. And so what that gets us is 3 over 6 plus 2 over 6. So that's the same thing, essentially. In terms of actual value, we haven't changed the value of either fraction. But now what we want to do is add the numerators. And we want to use the same denominator. We don't add the denominator. So our answer is still going to be over 6, but it's going to be the sum of 3 plus 2. And so that's going to get us 5 over 6. Okay? Does anyone have any questions about that? Awesome. So we can talk about an actual example then, bit of a trickier one. So we've got 3 and 2/5 plus 1 1/4. So we've got mixed numbers here. So we don't really want mixed numbers whenever we're adding or doing much of anything really. So we'll want to turn them into improper fractions. So we multiply the denominator by whatever our whole number is, our 4 by our 1 and our 3 by our 5. And then add whatever's left on top. So for the first one, it's going to be 3 times 5 plus 2 over 5. And then the second one is going to be 1 times 4 plus 1 over 4. And yes. Yes, you can go to the bathroom. And so what that leaves us with is 17 over 5 plus 5 over 4. Does that make sense? Awesome. So now we're going to need to find the lowest common denominator. So what is the lowest common denominator between 5 and 4? 20, yeah. So an easy way to do it, you can always get a common denominator, not necessarily the lowest one, if you just multiply the two values together. But sometimes you can reduce it a bit and get something that's nicer to work with. But yeah, so we want to get both of these to have a denominator of 20. So this one we're going to multiply by 4, by 4. That one gets by 5. And so we get 68 over 20 plus 25 over 20. Okay, and now what we do is we just add the numerators. So we want to find the sum of 68 and 25. Can anyone tell me what that is? Yep. 93, exactly right. So that gets us 93 over 20. And can we reduce this at all? Is there any common factor between 20 and 93? I don't think so. Yeah, 93, it's got a factor of 3, but that doesn't go into 20. And then that's pretty much the only one that would have been helpful. So yeah, 93 over 20 is where we'll leave it. All right, up next, we've got negative 3 over 4 minus 5 over negative 6. So instead of giving it to us in whole numbers here, the way that they've messed us up is by giving us a ton of negatives. So let's just clean that up quickly. So here we've got 2 negatives. That's going to make it positive. 2 sticks make a plus. And then over here, we've also got 2 negatives, so it's going to be positive. So that makes it a lot simpler. It's just going to be 3 over 4 plus 5 over 6. Okay, and then to get the lowest common denominator, we could just multiply 4 by 6, but there's actually a smaller one that we can have. So can anyone tell me what the lowest common denominator is? Yep.
12.
Yeah, exactly. 12. If you multiply 4 by 3, you get 12. If you multiply 6 by 2, you get 12. All right, so 3 by 3, that's going to be 9 over 12. 5 by 2 is just going to be 10 over 12. And then what is 9 plus 10? Should be one you can do in your head. Yep.
19.
Yeah, exactly. So we're left with 19 over 12. And then 19, I believe, is a prime number. So it doesn't have any factors other than 1 in itself. And if you ever end up with a prime number as the numerator, then you're probably done reducing. So 19 over 12 is where we'll keep that one. Okay, then we'll do one more of these. So we've got 2 and 8/7. So in this case, they've given us a mixed number that also has an improper fraction as part of it. So that's kind of annoying, but we deal with it the same way. And then we're adding minus 2 over 3. And that's the same thing as saying subtracting 2 over 3. So we can express it like that as well. So if we deal with this one, we got 2 times 7 gets us 14. Add the 8, that gets us 22. So that's 22 over 7 minus 2 over 3. Okay. Our lowest common denominator here, can anyone tell me? Lowest common denominator between 7 and 3. Yep.
21.
21, exactly. So in this case, just multiply them. So that gets us 22 times 3, which is 66 over 21. And then the 2, we need to multiply by 7, gets us 14. Okay. And now we're subtracting 2 numbers, but the process is the same. We're essentially, we keep the denominator the same. The only difference is we're just going to be subtracting these numbers, the numerators, rather than adding them. It's the same thing. If you want to think of it as adding a negative number, that's also the same thing, whatever you prefer. But yeah, if we, what's the difference between 66 and 14? Can anyone do that in their heads? Yep. 52, exactly. So that gets us 52 over 21. And I don't believe that can be reduced either. So that's where we'll leave it. Does anyone have any questions about this? Great. So there's there aren't any specific problems for practice on this one, so I'm going to leave D and E for you to do later. And we'll move on to the next page with problem 2. So problem 2, all it is we're adding in other kinds of operations. So now we need to consider our order of operations, our bed mass. But otherwise, it's just going to be the same stuff. So for A, we've got 1/2 minus 3 times 1 over 3 plus 2. So with BEDMAS, the first thing that we have there is brackets. So we're going to want to resolve whatever's in our brackets first. So that's the same as saying 1 over 2 minus 3 times. And we want to put this one in terms of lowest common denominators. Now 2 doesn't look like a fraction, but we can always divide by 1. So essentially we just want to find the lowest common denominator between 3 and 1. So what is that going to be?
3.
Yeah, just 3. Simple as that. So 1 over 3 can stay the same. And then the 2 is going to have to multiply by 3. So it's 6 over 3. Okay, and then we can carry out the addition. So that's equal to 1/2 minus 3 over times 7 over 3. Okay, so the next thing we'd want to do, well, BEDMAS, we don't have any exponents in here, so the next thing would be divisions and multiplications. And we do have a division or multiplication where we have 3 times 7 over 3, or I guess minus 3 times 7 over 3. So we'll put 3 in terms of fractions as well. And is there anything we can do to make our life easier here before we actually go ahead and do 3 times 7, 1 times 3? Can we cancel out anything here? Yeah? Exactly. Yeah, we've got a 3 on the top here and a 3 on the bottom. So they cancel out. It's going to be essentially 1 over 1 times 7 over 1. And so that's just going to be equal to 7. But I'll keep it as a fraction right now. So we have 1 over 2 minus 7 over 1. Okay, and then once again, we just have a subtraction, so we need to put it in common denominators. So we've got 1 over 2 minus, obviously, if something, the denominator of something is 1, the common denominator is just going to be what the other denominator is, which is 2 in this case. So it's going to be 14 over 2. And then there we go. So can someone tell me what the final answer is going to be? What's 1 over 2 minus 14 over 2? All right. Well, it's just going to be 1 minus 14 divided by 2. And 1 minus 14 is going to be negative 13. So then the answer is going to be negative 13 over 2. Does that make sense? Okay, good. Now we have B. So for B, we've got some other stuff going on, but once again, we're going to start with our brackets. So we're going to look into here. Okay. So once again, we've got 6 and 2, and we need to find the lowest common denominator. Because 6 is a multiple of 2, we can just use 6 as our denominator. So this is going to be equal to 5 over 6 minus, and then we need to multiply 2 by 3 to make it 6. So it's going to be 3 over 6. And that's going to be cubed. And then we're going to divide it by 2/3 in the end. All right. So the next thing we do is going to be actually resolving this subtraction. So 5 minus 3 gets you 2. So that's equal to 2 over 6 cubed. And I'm also going to flip this one around. So instead of having divided by 2 over 3, I'm just going to say multiplied by 3 over 2. We won't be doing that just yet, but just before we forget to do it, I'm going to do that there. So when you have 2 over 6, is there a different way we can represent that? Is there a better way we can represent that? Yep.
1 over 3.
Exactly. You can reduce that to 1 over 3. So let's do that right now. Okay. And now what we have is we have 1 over 3 cubed. So Mr. Mackay taught you a little bit about that. How if you have a fraction that is cubed or raised to some exponent, the way you resolve that is you have to apply that exponent to everything. So in this case, that means we have 1 cubed over 3 cubed. 1 cubed is easy. 1 cubed is just 1. 1 to any exponent is just going to be 1. And then 3 cubed. Can someone tell me what 3 cubed is going to be? 27, exactly. 3 squared is 9, then times 3 again, 27. Okay, so we've got 1 over 27 times 3 over 2. So before we do this, is there anything we can do to make our life easier here? Anything we can cancel out, perhaps? This one's not super obvious. But what you can do is you can see that 3 and over 27, that's just 1 over 9, because 3 times 9 gets you 27. So we can make that simplification. I'm just going to bring it up here. So that is the same thing as saying then 1 over 9 times 1/2. Are people good with that? Yep. Okay. And then the last thing we do is just carry out this multiplication. So we multiply the numerators, that gets us 1. And then multiply the denominators, that gets us 18. So the final answer is just going to be 1 over 18. And yeah, anything that has 1 as the numerator, you're not going to be able to reduce that either. So 1 over 18, we know that's gonna be it. So I'll talk to about number C, or letter C, I guess. For C, we've got just some additions and subtractions, so it's a bit simpler. We've got 11 over 9 plus negative 4 over 3 minus negative 5 over 6. So the first thing we're going to do, just cancel out those negatives. We don't really want those here. So that's equal to 11 over 9. And this is up to you, but I am going to just turn this adding a negative into a subtraction. So at any point, you can, if you have a plus and a minus, that's just the same thing as a minus. So we have 11 over 9 minus 4 over 3. And then the two minuses make a plus, 5 over 6. And what we can do is we have an addition and a subtraction, but we can actually carry them out at the same time. And the way we do that is if we find a common denominator of all 3 numbers. So we need to find a number that is a multiple of 3, 6, and 9 at the same time. Is there such a number?
18.
18, exactly. Yeah, so 6 times 3 is 18, 3 times 6 is 18, and 9 times 2 is 18. So we can do this all in terms of 18. So the 9 we multiply by 2, so that's 22 over 18. And then the 4, we need to multiply that by 6, so that's 24 over 18. And then the 5, we just multiply by 3. So we've got 15 over 18. And now that we've got 3 things that are all over the same denominator, we can add them all at once. So I'll just show you how that looks. So we can do that. 22 minus 24 plus 15, all over 18. So could someone tell me what is 22 minus 24 plus 15? Yep.
13.
13, exactly. So the 22 minus 24 gets you minus 2. And then 15 minus 2 is 13. So that's that. So we got 13 over 18. And then once again, we've got a prime number as our numerator, so we can just leave it like that. 13 over 18 is as simple as it's going to get. And then for D, we've got some additions, and once again, we've got multiplications. So first things first, we'll rewrite it in a simplified form. So we've got negative 1/2 plus, and I'm again going to just do minus 9 over 4. Actually, no, for this one, I'm going to just keep it as it is. You'll see why. And then this one, 14 over 6. there's a couple things we can do here. First off, we've got negatives on the top and the bottom, so that's going to cancel out. But also, we've got 14 over 6. Is there a way that we can reduce that? What's something that is a factor of both 14 and 6? Yep, 2, exactly. So if we divide them both by 2, we get just 7 over 3. Just like that. Yeah, so that will be that. So now we need to do the multiplication. That's going to be the first thing that comes in our order of operations. So we've got minus 1/2 plus, and yeah, we could just do this straight up, or we could try and do a simplification. The 9 and the 3, that's going to be equal to, so 9 over 3 is just equal to 3 over 1. So we can then rewrite it, if you'd like, as negative 3 over 4, times 7 over 1. And then that makes it a little bit easier to work with. The nice thing also about doing these cancellations before you carry out any multiplication or whatever is that it usually gets you into the reduced form. Like, it gets you closer to the reduced form. Because otherwise, if I had just done 9 times 7, that gets me 63. 4 by 3, that gets me 12. 63 over 12 would not actually be the most reduced form it could be, because we could divide it by 3 to get what our actual answer is, which is negative 21 over 4. Okay. Now all that we have left to do is this addition. You can also think of it as a subtraction because we're adding a negative. And so we just need to find our common denominator. With 2 and 4, that's pretty easy. It's just going to be 4 because 4 is a multiple of 2. So then we've got negative 2 over 4 minus 21 over 4. And in the end, we'll get negative 23 over 4 as our answer. Anyone have any questions about any of that? Awesome. So once again, we'll leave the next 2 questions for our practice later, because I want to show you at least one of these. So for problem 3, we're going to be evaluating these expressions for a given value of a, b, and c. So they've given it to us just in terms of these variables, a, b, and c. And what we want to do is we want to substitute their actual values as given and carry out the operations. So in this case, we've got a times b minus a times c. Just remember, when 2 variables are next to each other, that means that they're being multiplied. Just like 2 things that with brackets next to each other means multiplication. Same thing with the letters being next to each other. And that's why you'll never see a variable that is represented by 2 letters at once, or very rarely anyway. So a times b minus a times c. A is going to be minus 2. So I'll plug in that. B is going to be 3. So I'll plug that in. And then subtract the minus 2 times c, which is minus 2 over 3. And at this point, we can just treat this as one of our other problems. We can just apply BEDMAS, apply the order of operations. So the first thing we want to do is do our multiplications here. So minus 2 times 3. That just gets you minus 6. And then over here, we've got minus 2 times minus 2 over 3. So we can think of that as minus 2 over 1. And we've got 2 negatives, so those are going to cancel out. So that leaves us with 4 over 3. because we've got 2 times 2 gets us 4, and then 1 times 3 gets us 3 as our denominator. Okay. So once again, now we've got our addition and, in this case, subtraction. We want to find our common denominator. This we can think of as negative 6 over 1. So our common denominator is just going to be 3. Because, yeah, we've got 1 as one of our denominators, and 1 has every other integer as a multiple. So that's good. So that leaves us with negative 18 over 3 minus 4 over 3. If we add negative 18 and minus 4, what that gets us is negative 22. So we have negative 22 over 3 as our final answer. All right. And then for b, it's the same thing, except we've got a square in here. We've got b squared. But the process is the same. We start just by substituting everything in. So it's going to be 3 squared. And then we're adding a plus c. So a is going to be negative 2, and c is going to be negative 2 over 3. So we can resolve this first. The 9. So 3 squared gets us 9. And then figure out what's going on in the brackets. So minus 2, we can think of that as minus 2 over 1. So that's going to have 3 as a common denominator. Multiply both the top and the bottom of the 2 over 1 by 3. Gets us minus 6 over 3. Minus 2 over 3. And then we can carry that out. So that's 9 plus minus 6 minus 2 is going to get us negative 8. So we have negative 8 over 3. Okay, we're almost done here. What we need to do is just carry out this addition. So figure out our common denominator is going to be 3. So we have 27 over 3, 9 times 3, minus 8 over 3. And when we do that, we are left with 19 over 3. And once again, we've got something that we can't reduce. 19 is a prime number, so that would be that. Any questions about anything we just did? Yeah, hopefully you've done addition and subtraction of fractions before in elementary school, and this was just review. So yeah, I'm glad that you all understand it. So for practice problems, I guess we have on the first page 1D and 1E. And on the third page, we've got 2E and 2F that we didn't go through. So we'll be able to have those as practice problems.